Hello guys and welcome to this new tutorial where we're going to learn about voltage, current and resistance. These three concepts are going to be repeated over and over and over again throughout this course, and we need to have a good understanding about how things works with them. So let us assume the following. We have two tanks and they have an output. This output is different between the first tank and the second tank. One of them is wider, one of them is narrower. However, both tanks has the same height and they're using the same pressuring apparatus over there. These two tanks are really simple. We just press from above and we are going to get a water spilled from the output. See now, when we press down the tank on the right hand side, we are going to inflict the pressure at the output of the tank. Since the area of the output is much less than the area of the tank, a resistance is going to be inflicted at the beginning of the output. This resistance will try to prevent water from spilling out of the tank. Hence, the more the resistance, the more the pressure we have to apply in order to make the water spill out of the output. Now, if we press down on the tank on the left-hand side, we will see that we will have less pressure. That's due to the fact that the area of the output is wider than the area of the output of the first tank. It means we will have less resistance when we press the water out of the tank. Less resistance means less pressure and we can press more easily. We can also see that the amount of water being spilled per second will also vary between the two tanks. So, since the tank on the right has a narrow output, which means high resistance, we are going to get less water coming out of the output per second, causing to have a slow flow rate. Now on the left hand side, when we press the tank, we have a wide output here, so we have a low resistance as we mentioned. Now since we have a low resistance, we can have the water flow from the output more easily, and the amount of water that is flowing per second will be larger than the first tank. Now we can simply tie these concepts with voltage, current, and resistance concepts. The pressure we apply is the voltage. The water flow is our current. And the tank resistance is our electrical resistance. Higher resistance means we need higher pressure in order to get higher flow rate. And this relationship is given as voltage equals current times resistance. So it is an interconnected relationship that changing one parameter will affect the other one.